Let us look at question number 33, students. Match the acids given in list 1 with some of their characteristics given in list 2. Okay. So if we talk about the first acid, students, it is given to us that it is sulfuric acid. So if we talk about sulfuric acid, it is H2SO4. Okay. So we can try and draw the structure. So this is the structure of H2SO4, students. Okay. So let us start with the options given in list 2 now. So first option, it says percentage of O lies in 63% to 66%. So if we talk about the total mass of H2SO4, students, its molar mass is 98. And if we talk about oxygen, so there are 4 oxygen atoms. So the percentage of oxygen will be 64 upon 98 into 100. So students, this will approximately come out to be equal to 65.3%. Okay. Students, 1 will be a match with P. If we talk about the second option now, hybridization of central atom or atoms is sp3. This is also correct, students. Sulfur is sp3 hybridized in this case. If we talk about the third option, it says basicity of acid is equal to 2. So the basicity of acid is equal to 2. It is a dibasic acid, students. So 3 will also be a match. If we talk about the fourth option now, it says that the number of pi bonds is equal to 2. So we can clearly see that the H2SO4 molecule contains 2 pi bonds. Okay. So 4 will also be a match, students. So we can clearly see that the fourth option is going to be the answer to this question, students. Only option D matches P with 1, 2, 3 and 4. Okay. Let's look at the second acid now. It is perchloric acid. So students, perchloric acid is HClO4. Okay. So we can draw the structure again. So Cl double bond O, double bond O, double bond O and OH. Okay. If we talk about the molar mass of HClO4, students, its molar mass is 100.5. And if we talk about the mass of oxygen, it is 64 grams. So if we talk about the percentage again, so 64 by 100.5 into 100. So this will be a little shy of 64%, students. It is approximately 63.7%. Okay. So students, the first option will be matched with option Q. So perchloric acid will be matched with 1. If we talk about the second option now, hybridization of central atom is sp3. This is also correct, students. Chlorine is sp3 hybridized in this case. So 2 will be a match, students. Option 3 will not be a match. The basicity of the given acid is 1 and not 3. So 5 will be matched, students. And if we talk about the fourth option now, fourth option will not be a match. It contains 3 pi bonds. Okay. If we talk about the third option now, which is oxalic acid. So students, oxalic acid is H2C2O4. Okay. Its molar mass is 90 grams. And if we talk about oxygen present are 4 in number. So the percentage will be given by 64 by 90 into 100. So this is greater than 70%, students. So this option R will not be matched with 1. If we talk about the second option, hybridization of central atom is sp3. So we can draw the structure of H2C2O4. We have C double bond O, C double bond O, OH and OH. Okay. So the central atom or atoms are sp2 hybridized and not sp3 hybridized. So second option will not be a match again. If we talk about the basicity, so there are 2 OH bonds and both of them will be donated. Okay. So basicity of acid is equal to 3 is equal to 2. So third option will be a match, students. If we talk about the number of pi bonds, it's 2. The oxalic acid, it contains 2 pi bonds. So 4 will also be a match. Okay. Fifth will not be a match. Okay. If we talk about option S now, which is phosphoric acid, so H3PO4. So this is the structure of H3PO4, students. The molar mass is 98, and so the percentage of oxygen will be exactly the same as in the case of sulfuric acid. So oxygen content is 65.3%. So S will be matched with the first option. Hybridization of central atom will be sp3. Phosphorus here is the sp3 hybridized. So 2 will also be a match. If we talk about the third option now, basicity of acid is not 2, it is 3. So 3 and 5 will both not be matched with option S. If we talk about the number of pi bonds, there are only 1 pi bond present. So option 4 will also not be a match. So students, we have the correct matching for the acids given in list 1. So we have to mark the correct answer as option D. Okay. Let us look at the next question now. Let us look at question number 34. So match list 1 with list 2. So list 1 contains some mixtures, while list 2 contains the properties of solute or the remaining acid base after neutralization. Okay. So if we talk about option P now, we have 6 gram NaOH present in 250 ml of H2O. Okay. So if we talk about option P now, students, we can extrapolate it to 1 liter. So we have to multiply it by 4. So it contains 24 gram of NaOH present in 1000 ml of water. Okay. So if we talk about the moles of NaOH present in 1 liter, students, so there are 0.6 moles, and the volume of the solution is to be assumed as the volume of the solvent, as the examiner has told us that there has to be no volume change during mixing. Okay. So there are 0.6 moles in 1 liter. Okay. So students, the molarity for this solution will be given by 0.6 molar. So 1 will be a match. If we talk about the molality now, so the density of water is 1 gram per ml. So it does not matter if we have 1 liter water or 1 kg water, both are the same. So there are 0.6 moles of NaOH present in 1 kg as well. So the molality will also come out to be equal to 0.6. Students, 2 will also be a match. If we talk about the mole fraction now, so we have moles of NaOH which was 0.6, and now if we talk about the moles of water in 1000 grams, so we have 55.55 moles of water. Okay, so we can have the mole fraction now. So the mole fraction will be 0.6 divided by 56.15. So this approximately comes out to be equal to 0.01. So the third option will also be a match, students. So if you talk about the fourth option and the fifth option, they will automatically not be matched. Okay. Let's look at the second option now. In the second option, we have 54 gram of glucose present in 500 ml of H2O. So similarly, we can extrapolate it again, students. We can have 108 gram of glucose in 1000 ml of H2O. Okay. So if we talk about the moles of glucose present, the molar mass of glucose given to us, it is 180, students. So if we talk about the number of moles of glucose, it will again come out to be equal to 0.6 grams in 1 liter. So we can clearly see that the option Q will have the same answers as option P. Okay. So it does not matter if it is 1 liter or 1 kg. The molality will also be 0.6 and the molarity will also be 0.6. And the mole fraction will come out to be exactly the same as in the previous case, which was 0.01. Okay. So all of 1, 2 and 3 will be matched with option Q. Okay. Let's talk about the next option now. Option R. We have 50 ml of 1.4 molar NaOH. So we have 70 millimoles of NaOH. And if we talk about HCl, students, we have 10 millimoles of HCl. Okay. So we can clearly see that there are 60 millimoles of NaOH present in 100 ml. Okay. So the molarity will again come out to be equal to 0.6, students. So it is also again going to have the same answers as the option P and option Q. So molarity is 0.6. Molarity will also come out to be equal to 0.6. And since we're dealing with aqueous solutions again, the mole fraction will also come out to be equal to 0.01. Okay. So option R will also be matched with 1, 2 and 3. Okay. Let's talk about the last option now, students. In the last option, we have 31.2 gram of benzene mixed with 55.2 gram of toluene. Okay. So if we talk about benzene, benzene is C6H6. Its molar mass is 78 gram per mole. So if we talk about the moles of benzene present, students, we have N of C6H6 equal to 31.2 divided by 78, which gives us a value equal to 0.4. If we talk about toluene, students, toluene is C6H5CH3. Okay, its molar mass is 92 gram per mole. Okay, so if we talk about the number of moles of toluene present, So we have to divide 55.2 divided by 92. So this will come out to be equal to 0.6. Okay. So students, we have 0.4 mole of benzene present in 0.6 mole of toluene. Okay. The density of toluene is given to us, students. It is 0.87 gram per cc. So the volume of toluene will be less than the 55.2 grams which was given to us. So students, the 1, 2 and 3 option will not be matched. It was corresponding to a molarity of 0.6. So in this case, we can clearly see that the mole fraction will come out to be equal to 0.4 as the total of 1 moles are present, and out of that benzene is the solute and it contains 0.4 moles only. So fourth will be matched to option S, students. And if we talk about the last one, which is the molarity, so for molarity we have to divide the moles of benzene present in the total volume of solution. So students, we have 0.4 moles of benzene present in 55.2 divided by 0.87 mLs. Okay. So this number has to be multiplied by 1000, students, and if we talk about the resultant molarity, it comes out to be equal to 6.3. Okay. So students, the fifth option has to be matched with option S. So if we look at the options which are given to us, students, we can clearly see that the correct answer to question number 34 is option B. Let us look at the next question now. Question number 35. Match the orbitals given in list 1 with the number and the type of nodes given in list 2. Okay. So the first orbital is 3s orbital. So if we talk about 3s orbital, students, the value of n is equal to 3, the value of L is equal to 0. So if we talk about the number of radial nodes, students, it will be given by n minus L minus 1, which shall be equal to 2. So if we talk about P will be matched with 1. It has 2 radial nodes. If we talk about the number of planar nodes or the angular nodes is given by the L value. So it has no planar nodes or no angular nodes. So it has to be matched with 4 as well. Let's look at the second option now. We have 4px. Okay. So if we talk about the second orbital, we have 4p. So if we talk about 4px orbital, students, the value of n is equal to 4, the value of L is equal to 1. So if we talk about the number of radial nodes, it will be given by n minus L minus 1, which shall be again equal to 2. So it has 2 radial nodes again. So 1 will be a match. If we talk about the number of planar nodes or the number of angular nodes, the number of angular nodes is given by L equal to 1. So it has 1 planar node or 1 angular node. So it has to be matched with 2 as well. Okay. No other option will be matched with option Q. Let's look at the R option now. We have 4d x square minus y square. Okay. So the value of n is equal to 4. The value of L is equal to 2. Okay. If you talk about the number of radial nodes now, it is 4 minus 2 minus 1, which is equal to 1. So it has 1 radial node, which is given in the fifth option. Okay. And if we talk about the number of angular nodes, the number of angular nodes is equal to the L value. So it has 2 angular nodes. So we have to match the third option as well. Okay. Let's talk about the fourth option now, which is the 4dz square. Okay. So in 4dz square again, we have n equal to 4 and we have L equal to 2. So the number of radial nodes shall be equal to 1. So 4 minus 2 minus 1 is equal to 1. So students, it has 1 number of radial nodes, so 5 will be a match. If we talk about the planar nodes, 4dz square has no planar nodes. It has 2 angular nodes, both of which are conical in shape. So it has 2 angular nodes, so 3 will be matched. It has no planar node, 4 will also be a match. It has 2 conical nodes. Okay. So if we look at the options which are given to us, we can clearly see that for question number 35, we have to mark the correct answer as option A. Let's look at the next question. Question number 36. Match the electronic transition given in list 1 with their wavelengths and the region they belong to in list 2. Okay. So students, if we talk about the option P now, we have transition from n equal to 13 to n equal to 5 in z equal to 39. So we can apply the Rydberg's formula, students. We have 1 by lambda is equal to r into z square into 1 by n1 square minus 1 by n2 square in a transition from n2 to n1. Okay, so if we talk about the option P now, students, we can have 1 by lambda is equal to R into Z. The value of Z is 39 square into 1 by 5 square minus 1 by 13 square. So this on simplification will give us a value equal to R into 39 square into A plus B into A minus B. So we have 18 and 8. So 18 into 8 upon 5 square 13 square. Okay. So this on simplification will give us a value equal to R into 1296 by 25. So if we talk about the lambda value, students, the lambda value will be equal to the one given in the fifth option. So 5 has to be matched with P. And if we talk about the region in which this lies, students, so we know that the first line of the Balmer series of hydrogen lies in the visible region. So if the lambda is less than that, we can conclude that it will lie in the UV region. Okay. So students, this number is very less than the one corresponding to the first line of the Balmer series in hydrogen atom. So this will lie in the UV region. So first will be a match, students. If we talk about the second one, so we can solve for Q as well now. So for Q, similar calculation has to be done. So 1 by lambda is equal to R into 48 square into 1 by 4 square minus 1 by 5 square. So if we simplify this number, we are going to obtain 1296 R by 25 again. So it has a similar answer as the P option. So it has to be matched with 1 and 5. Okay. If we talk about the R option now, students, in the R option we have Z equal to 2 and N equal to 3 to N equal to 2. Okay. So 1 by lambda is equal to R into Z square. The value of Z is 2 square. And if we talk about N1 and N2, they are 3 and 2 respectively. So 1 by 3 square minus 1 by 2 square. Okay. So this on simplification will give us a value equal to 5 by 9R. So if we talk about the value of lambda, students, it will be the one given in the second option. So 5R by 9. So 2 will be matched, students. And this particular lambda also lies in the UV region. So 1, 2 will have to be matched with R. Okay. If we talk about the last option now, we have the transition from N equal to 3 to N equal to 1 in Z equal to 1. So we have 1 by lambda is equal to R into 1 square into 1 by 1 square minus 1 by 3 square. So this on simplification will give us a value equal to R into 8 by 9. Okay. So the lambda value will be given by 9 upon 8R. So 9 upon 8R is given in the fourth option. So this wavelength also lies in the UV region. Okay. So if we talk about the option which is correct, we can clearly see that for this question we have to mark the answer as option C. So this is it for today, guys. I hope the solutions were clear to you. Thank you.